Testing voice. Voice test. Testing voice. Voice test. Testing voice. Voice test. Okay. Sounds okay. Alright. So, I'm gonna continue where I left off. Of course, FSD beta was not released. It was delayed again. What is this? 5 years in a row of delays? But you know, Elon said Sunday or Monday, which means definitely not Sunday and definitely not Monday. Anyway, that just means that those of us with 100 scores may have to keep up the charade for another couple days, couple weeks, who knows. Or maybe they locked in scores Friday midnight. We don't know that either. But I did drive today. I mean, I had to. I was hungry. And I logged about 40 miles today. Still at 100. Today's average is 100. It was nerve-wracking though, because I did get cut off about 3 or 4 times. And each one of those is potentially a ding on the unsafe following metric or the Ford collision warning metric. Okay, continuing. Manual cue input, keyboard support, which I did in the previous stream a few hours ago, and finesse calculation mode. Finesse calculation mode is a little buggy. It's working fine if you're just letting the bot play by itself, but there's a bug that happens when the user tries to input their own moves, and I believe I figured out why that is. And it's this. Here, whenever the bot button is pressed, which is this button, the bot makes its move. Okay, that's all it does. So each time I click, 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 click. Each time I make a move, the bot. This method is called bot pressed. Now let's see what's happening in this method. First, it checks if the cold clear instance is has been initialized, and if not, then pressing bot doesn't do anything. So in the case where you just fire up the game, the bot hasn't been initialized yet under the covers, pressing bot won't do anything. Okay, and then after we do the check for the cold clear instance, we do something called requesting a move. And cold clear can request a move if the instance is initialized, which means we've provided a few parameters to the bot. Okay, so the bot can be initialized with options. So you can tell it what weights to be. You can decide whether or not you want the bot to allow holds. So if the bot can make the move hold or not. You can tell it with the current pieces. You can tell it what the next pieces in the queue are. And this is how it makes its predictions. And every time that happens, every time the bot plays a move, you have to add another piece to the end of the queue. And there's a method to do that, and actually it's right here. So, requesting next move. The bot will in the C API. So if I were to natively be calling this method in C, I believe the bot either blocks until a move is found, and while a move is not found, it'll return move awaiting or waiting for move or bot dead or something like that. So that's what can happen. And there's another move. There's another API call for requesting a next move that spins, I believe, and then you can spin wait on it until there's a return. Either way, this method returns you what the move is, and what the move is a series of button presses to get a piece where it wants to go. So let's say the bot wants to move a piece. Let's get a clean projection so that we can see this. Okay, as you can see, this piece wants to go here. The bot wants that L to go here first. That L is, the second L is, I presume, this one, but the first one goes here. So the CC move that's returned will be a series of button presses like rotate right, rotate left, tap left, and the last move is always drop, so that's actually implied. So there's not actually a hard drop command, it's just the last thing that you do after you exhaust the list of moves that it gives you. So this one, and I'm just making this plan up, but it could be counterclockwise, tap left, hard drop. And so that's what this method does. It takes the moves, and for each move that we get, excuse me, each move that we get, actually perform the move. And unfortunately, since every call of this method happens in a single frame, we don't get to see the moves in action. I tried to see the moves. That's why here, when you press the bot, the moves seem to pop instantly into place. That's because every single move is done in a frame. So there's no, the moves that are being made are not discrete frame wise, unfortunately. It's a kind of a cool animation to see the pieces move by themselves, but it's a lot of work to re-architect this to work from the frameness that it is on now. Okay, requesting next move returns you the move that should happen and the plan placement. Now what the plan placement is this piece projection here, which is buggy, as you can tell. It doesn't always work, but when it does work, you can clearly see what the pieces, where they want to go. This L piece goes here, this I piece comes out of hold, goes on the right, this J piece gets thrown here on the left. And of course, it doesn't always do what it says it's going to do, because depending on what the next cue is, it may change its mind. So let's say you could only see these two pieces, and let's say the bot has decided where it wants these next, this S and the L to go. Once it sees the next pieces in the queue and decides, oh, I can place these in a more optimal way, it'll just disregard whatever plan it had before and execute the new plan with the new pieces. So it's you can sort of think of it as it's making its plan on a rolling basis and not discretized on some section of the bag. Pardon me. Okay. Now in the move parameter, there's a hold. If the hold button, as you notice, is not part of this move list, it's provided as a property. So if there's a hold, if hold is set to true within this CC move, then the first action that you have to perform is a hold, and then the moves that come afterward are the movements that you need to apply to the piece that was just in hold. Okay. Okay, that needs to stay, obviously, because that's part of the movements. We only want movements in the bot pressed. Now, let's see where we can... Here. Wherever this is being set, we can probably do the request move. And the piece projection. Yeah, the piece projection and the request move, let's move it out. Wait, where was I? Okay, that's bot waits initialize with current state. Looks like it's just used in these three places. Okay, that's good. So we initialize it here. Okay, now let's try to get the moves. That means this will need to be property on the class. I don't know why my CPU is working overtime right now. Liemtris. I thought I killed this. Oh no. Nope. Where were we? Liemtris? No. I gotta remember what these types are. CC move. Request new move returns a tuple of CC move and an array of plan placement. Okay, let's make those optional. Alright, where's cold clear? Cold clear, here we go. var cc move cc move var cc plan placement is an array of cc plan placement. And my computer is Xcode is being very sluggish right now. Let's see what's going on. I'm just gonna quit it and reopen it. Let me type something to see if it's better. Not really. Self.cc plan placement. Okay, now back to our bot pressed. Here we go. Okay, CC move hold. What else do we need to move out? Plan placement. All right. Let's see. This should be okay. Let's see what happens. Ah, right. Of course. Oh, yikes. Request next move. What is this? It's in cold clear. Where was this called from? is this a bad request? CC bot is no? Hasn't this already been done though? It's this, right? Because this isn't a queue. I mean, this is being threaded. Let me try this. Don't need this. This should be okay now. I haven't even seen any performance increase by offloading that in a different thread. I don't even think I'm doing it right, so we'll see. Oh, right. This again. So this is a pretty funny bug. Yeah, not great. I don't think. It's a pretty bad bug. Wait a second. CC move. It's making the same move every time. That's, if you noticed, that's a good indication of what's happening here. So it's trying to go there, and everything else is being moved from there. So it's like tap right 3 times, and then do this. Or tap right. What is that? O starts here. So 1, 2, 3, 4. Yeah, I starts here. So it's 1, 2, 3, 4. Z starts here. So it's 1, 2. Wait. 1, 2, 3, 4, 5. So Z starts here. So 1, 2, 3, 4. S starts here, I believe. 1, 2, 3, 4. Yeah, so the move is not being updated. That's very clear because of this. Before move was being updated every time bot was being pressed. Now it's not. So we have to fix that. Request next move. Where was that being done? Just before the bot went. Just before the bot went. Now we need to do it just after the bot goes. God, I hate that. This is a classic fence post problem. I really don't like that we have to call it in 2 separate places. It makes debugging it can make debugging very confusing. This is almost as egregious as mucking with your loop variable inside the loop. All right, So let's do it. Where does projection come in? Now I'm confusing myself. Before projection was being assigned, just after the bot was pressed. But it wasn't working when I hard dropped to myself. I don't remember why. Excuse me. The bot was being pressed manually, and that allowed the projection to work. But when I hard dropped to myself, it didn't work. Oh, I forgot the reason. Anyway, that doesn't matter. We don't need to remember it. We just need to rederive it. I think I had a comment up there, but now I really want to figure it out myself. Piece projection. Why did projection not work when I hard dropped to myself? When I hard dropped to myself, why didn't it work? When I hard dropped to myself, the piece projection, excuse me, shows up. Piece projection. Right. Because when I placed it myself, bot pressed wasn't happening. And in bot pressed, that's where this stuff happened. Projection being assigned, move. Yeah, so game projection needs to happen. Actually, this should be, yeah, this should be fine. That's the whole point of putting this inside. I need it in here, but I also need it outside. Huh. I also need it outside. So in both places. Is this valid syntax? Why? I just want to see if this works. Okay, projection is still on after I place that myself. See what happens here. Yo, it's working. Oh my god. This just doesn't happen, man. Okay, now I'm seeing two pieces. I know why. Because we did this earlier thinking that it was the fix. I need to change this. Because not even one was showing up. I want to just see if it was an off by one. Clearly not. Alright. That's calculation. No. Weird. There's no way this is freaking working right now. You know what? I would like to change this Liemtris to be whatever mode that it's currently on. That'd be pretty cool. Liemtris. Might be in storyboard. Color. No, it's here. So I need to set the name label depending on what the game mode is. I'm not gonna do that now. This will let users know what mode they're in. Oh, this DAS is just not working. I need to figure out why that is. See, this is the 6th column, and whenever I see this in the 6th column, I need to tap right. That's the whole point of calculation mode. This is in the 3rd column, that's 2. This is in the 4th and 6th column, which means I need to tap clockwise. DAS. DAS. This is just a tap left and a clockwise. This is a DAS left, counterclockwise tap right, DAS counterclockwise tap right. This is a DAS right, rotate counterclockwise and tap left. Three, 4, 5. 3, 4, 5 is where every piece of width 3 spawns. So I need to memorize this. I don't know why I have such a hard time seeing that. This should be really obvious, given that that's where every ghost piece starts at. 3, 4, and 5. 3, 4, and 5. This is in the smack dab in the middle. This is 5 and 6 for the O piece. It's the only piece of width 2. What happens if I place it in the wrong spot? Nothing, it just updates right away. My god. What happens if I do this? It updates. That's nutty. Oh my god. That's freaking nutty. Okay, now this is, it has 4 pieces on the left. 4 empty on the left, and then 5 and 6. 5 and 6 for Z and S are just a clockwise. Clockwise. Come on. I just realized it even works on undo. Like, that's a miracle, because making all these things work as intended without explicitly accounting for it, it's like a gift on Christmas from Jode. Holy cow, that worked so well. You know what? Now I'm curious. Does projection work for real? I doubt it, because my algorithm that I used, yeah, it didn't work. I saw that. Yeah, see? It's not working. But it should be a much easier fix now that pieces are playing a little bit more well together. Okay. Yeah, see? And it's also working on the first invocation. So when I reset it, it's actually making a plan with the initial cue. That's great. That's awesome. Okay, let's commit this. Okay, what's next? Manual cue input. Excuse me. Do I feel like doing that though? Manual cue input is going to be a lot of busy work because of all the menus. I do want to do this though. Instead of typing the letters T, L, O, J, S, Z, all that, it'd be cool to have a button for each piece, and you just tap the buttons, and each button has a picture of the piece on it, which is going to be cute. But I gotta look up so much stuff to figure out how to do that. Oh, I really don't feel like that. How about something else? Forced look ahead calculation mode. Okay, so for this idea, let me just run it. Let me just explain what this is. Forced look ahead calculation mode. So whenever I'm practicing, and I'm sure almost everybody has this problem, because most people, and I'm not being hyperbolic when I say most people. I'm saying 99.9999% of people who play Tetris cannot look ahead. They can't do it. And to intentionally practice for it is very, it's not only hard, but because it's hard and you're so easily tempted to do it wrong, most people don't ever bother doing it right. So what I'm saying is, okay, where do I want to place this T? I think about it, right? Let's say I decide where to place the T. Now I have to decide where to place the O. And then where to place the L and the J. All this should be done in your head. But it's so easy to just to say, I'm actually gonna play. I can't figure out where that I is gonna go. I'm just gonna see where and then you just play, and then like I'm doing right now. Jesus Christ, like I'm doing right now. Oh man, I was hoping that bug was gonna automatically come for free. I guess not. It's still bugging out when I undo at some point. Ah, nuts. At least Finesse calculation mode is working. I'm gonna install this to my phone actually. This is a good place to... Oh, where's my phone? get distracted on my phone. That's the whole point of doing this stream, is that I don't get distracted. Fail. Where's my cable? I've got to plug this into my computer. For some reason the network option is not working. So let's plug this in and install it to the phone. Excuse me. You know what, now that I think about it, that bug with the DAS not working right happens on my phone too. At least I know it's not just a simulator thing, which would be really, really lame trying to debug. I don't know why it happens. Maybe I should just, when the app goes off screen, I should just deinitialize my CA display link objects. I could do that, but that's not really a fix. That's a workaround. It's a kludge. There's enough of that in this code base. Okay, let's name this branch something that I want to do next. Forced look ahead. Oh yeah, forced look ahead calculation mode. What this is going to be is not allowing the user to play pieces until you've confirmed what you want to play. Wait, now that I think about it, that doesn't really sound like, how could I see? The problem with that is, let's say you're forced to plan all of your pieces, right? Let's say you're forced to plan this entire thing right now. What's gonna happen is, just like the bot doesn't discretely make moves at some arbitrary point in the queue. For example, if it comes up with a plan and then it sees a new piece or a set of new pieces, it'll update the current plan. It won't just stick to what it's already decided on. But in this mode, if you see new pieces come up, like let's say I come up with a plan and I decide on it right now with this STLZIO queue. Let's say I place the S, and the next piece that comes in is obviously a J, but now let's say I've mentally placed the T in my head too, so the S and the T are placed. And then the next piece that comes in the next bag is, I don't know, let's say it's a J, or let's say it's another Z. But because I know the Z is coming up, I might want to change the plan that I already have. But that's not really possible if I lock these 6 pieces on the board. Whatever, it doesn't matter. We have to start somewhere. So, how are we going to do this? I need to physically not allow button presses, either after a certain time or the user has to hit a confirmation button for the next, and then they can place the next N pieces. And the N pieces will be based on what the next queue setting is, which we've already coded. Forced look ahead mode. This is going to be really useful for practicing, like truly calculating. Because the problem that most of us have is we don't actually calculate. Kind of just place pieces and hope that the next one works, which is exactly what I'm doing right now. Yeah, see? I didn't want to do that. You know what? This will definitely help me with sprint. My sprint time is god awful. My god, it's awful. Especially for somebody who's been playing as long as me. Maybe I need to update the hold or something. I don't know. This is awful. Jesus, next O is taking forever to come, which means I can't really use it. I gotta admit, I sure did choose the right thing to get obsessed with. I will never be bored of this until the day I die. Okay, so I've never explained this to anybody, and for good reason, it's not actually that interesting. But why Tetris, right? Like, why did I choose Tetris to sink my time into? Why, out of all things, this game, which is 20, 25, 30 years old, over 30 years old. Why am I choosing this in the age of hyper-realistic games? Easy. Actually, it's not that easy, but this game will always be a thing. That's my dog. This game will never go out of date. Tetris is not a speculative type of game. It will never go out of style, and people will be playing it long after I die. Which brings me to the second point. There is always going to be somebody to play with. Always somebody to destroy. Because that's what this is about. Is mentally destroying the other player. To see the look on their face when you've outsmarted and outplayed them. Number 3. And this is the result of, in my opinion, one of the most brilliant game design decisions of all time, is when they introduced the kick table. Okay, so the kick table is how pieces are kicking away from the edge of the board. So if you were to look at this piece, you see this center, and you rotate, it rotates about this center. You see that? Now, logically, if you think about it, if you move it here, you shouldn't be able to rotate it, because if this is the axis of rotation, if you rotate it downward to look like a T, this piece is going to be here outside the edge of the board, which is not going to work. So what happens is you have to kick. Okay, you have to kick, and see how it kicks away. Same here. If I were to rotate this piece, notice the center of rotation is this piece. See that? Now logically, if I put this here, I shouldn't be able to rotate at all in clockwise or counterclockwise, but it still works. Why? Because of a kick. And the other way, because of a kick. Now, these kicks are not arbitrary. I mean, their decision may have been, but you can the kicks themselves are they're deterministic. So what happens is you have 5 total kicks that the game tests for until it decides you can't move a piece. For example, let's see what happens if you can't really move a piece. Let's see, what can I do here? Oh yes, perfect example. I can do this. I can build a TST, and I can show you. Okay, so here's the double. Okay, now check this out. If I have, shoot, just make this a little bit prettier. Let's say put this here. Okay, notice here I can kick that. You see that? Kick this in. But if I rotate it this way, there's no kick that you can do. That means all the kicks, all the tests that it tries, fails. So the kicks that the game tries is, first of all, if you have it up against the wall here, it'll try kicking it out 1 to the right. That's one of the tests. I don't know if it's the first test, but it's one of the 5 tests, where the first test is just a normal rotation. So it's not, you don't really call it a kick because that's rotating without obstacles. If there's obstacles, then one of the next 4 kick tests will be tried. Here, all kick tests fail and nothing happens. I'm trying to rotate right now and nothing's happening. Right, left, nothing's happening. But this one works because this kick moves the piece to the right 1 and down 1. You see the axis of rotation moving there, and that's how the piece moves. The offset is from the axis of rotation, so it's moving right 1 and down 1. And this kick from north to west, one of the kick tests, I believe it's the fourth kick test, which enables the TST, is move right 1 down 2. See that? The center moves right 1 and down 2. See? Now, I'm only able to reverse the action because it just so happens that the reverse kick from west to north. One of those kicks is to move up 2 and left 1. Up 2 and left 1. You might think that all kicks should be symmetrical, but that's not the case, especially with with the eyepiece, the S and Z in some orientations, and the T itself. So for example, if we do this, you're going to see that I can kick the T in place, but I can't kick it out. Okay, so here I'll kick it into place, and I'll undo the action, but it doesn't take you back to where the piece was. See, so the piece starts here, okay? Kick it in, and notice it's pointing east. This is a east to south rotation, east to south, but south to east does not kick it back out. So not all kicks are symmetrical, and it's up to the player to know when this happens. And like I told you with the TST, this kick here, north to west, west to north, northwest, 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 northwest. See, this kick once again is it goes X and then Y, so it's a +1 -2. Okay, +1 -2, and then from here to here, this is a -1 +2. So it's a +1 -2, and from here to here, it's a -1 +2. And we can actually see the kick table here. Should show us this. So like I said, this is north to west, which in this nomenclature is 0 to L. So it's in the 0 position, which is unrotated, and L, which is left. So 0 to L, which is this row. If you do a 0 to L, for the T, it's +1 -2. Okay, because the center goes 1 to the right, 2 down. You'll notice that that's +1 - that's actually the 5th kick for the T piece. It's the last test. And conversely, if you go from L to 0, one of the kicks should be -1 +2. So L to 0 should be -1 +2. That's also the last kick test for this guy. And I believe Hard Drop has a good visualization for this. It tells you which kicks are useful. It was in Hard Drop. It even tells you about the T piece here. Useful kicks. Here, it's useful kicks. So here's the useful kick, which enables, and that's the 5th test, as you can see, for TSTs. So as you can imagine, writing this kick table in code was freaking beastly. I can show you an example. Get kicks. Designing this in a way that was like clean was nutty. Believe, yeah, so I has its own kick table and all the other pieces have their own kick table, as you could see here. And getting the math to work just right was, let's just say it's not fun to debug this. Okay, and there's just so many opportunities for errors. Okay, and what else did we want to do? Alright, so obviously 40-line sprint mode, that needs to be a thing, right? That's in basically every guideline Tetris guideline and third-party Tetris mode ever. This is the standard by which we measure a player's speed and thinking ability. It's the 40-line sprint mode, and it's to clear 40 lines as fast as you can. Now, these fast times, like for example, let's say an advanced player will finish in about 20 seconds. Intermediate, let's say 25 to 32 seconds, something like that. The beginners will do it in about 2 minutes plus, a little bit below that, maybe a minute 20. But these times that I've mentioned, like 20-second sprint time for advanced, that depends on the game. Because even though every game has the same kick table and finesse, because they all spawn in the same position, they all have the same axis of rotation, all the movement keys are the same. But where it differs is the line clear delay. So in games like my game, there's no line clear delay. Once you place a piece and you lock it in place, the line clears instantly. There's no animation, there's no sound, there's no delay. In games like Puyo Puyo Tetris, there's line delays to sort of handicap fast players, in a sense, because it's not really fun playing instant. It's not very pretty animation-wise, aesthetic-wise. Games like Tetrio, Justris, they have instant line clears as well. And in those games, 20 seconds seems to be where advanced players lie. Games with line clear delay, the most advanced players usually hit about 31, 32, 33 seconds. And of course, in those games, you really want to just be clearing Tetrises, because each time you clear like a single, double, triple, you're wasting time on the line clear delay animations. In games without line clear, it's less forgiving. It's more forgiving if you don't do all Tetrises, but you shouldn't do that. It's a standard that you should do all Tetrises, because for you to not be doing Tetrises, that means you're doing other things like needing to skim and creating eyepiece dependencies where you need to use your eyepiece in the stack, which are bad practices, and which means you're not planning ahead well enough anyway. So you should just be Tetrising in 40-line sprint mode. Now, this is such an important mode that I might just have to prioritize it. What's going to happen is I'm going to display a timer, and I'm going to have to count lines. And the timer begins when I move the first piece and ends when there are 40 or more lines cleared. Okay, and now that's not the only thing. I also have to store this in like a leaderboard section kind of way, so that you can keep track of your times. And this board should be sortable, and it should be offloadable to the cloud. You really don't want to lose this type of save, especially if you've been practicing and racking up hundreds or thousands of sprint times. So, you know what? I'm gonna have to add that. And I'm gonna have to make this a new page and save it to some other part of the app. I don't know where yet. Might actually also need like a survival mode, a true survival mode. The survival mode I have now adds lines every n, adds garbage, adds one line of garbage every n lines. But a cool survival mode, which will really up the pressure, is gonna be just like gestures as a survival mode. Your lines are being added every second or every 2 seconds or whatever the difficulty is, and it's continuously adding garbage to your board. That really adds on the pressure, just in a way that the way I've implemented it doesn't really add pressure. So mine works is it just adds every n lines, and you can see that here in choose game mode. So let's say every 3 lines we add garbage. Choose game mode. I don't know why that didn't work. Okay, let's see. Of course, the key here is not to stack over your garbage holes. I'm curious to know if the actually that's one of the next goals is to have the bot do down stacking. So this is actually it's pretty high up because how important this mode is going to be. Experiment to find the best bot weights or down stacking. So this will be the down stacking visualizer training mode. I should probably name it that. Um, what it's going to do is have the bot tell you, well, the bot is going to be able to calculate what the best down stacking moves are. And that's dependent on researching what the best bot weights for this mode will be. So there's a couple things that need to happen with this bot mode. It's going to need to manually set bot weights, which, I mean, automatically set bot weights through the code, which I haven't done at all. Every bot setting is done through these sliders manually, whatever you want it to be. So down stacking mode is going to automatically set those bot weights. We also need to do research to figure out what those bot weights are. And then on top of that, actually implement the mode itself. Which is not going to be that tough because it's just going to be, well, no projection, or maybe, yeah, projection should be fixed by then. I need to write all this down. So all these here are modes that I would like. Implement input game queue. I'll move it down here. This spin, this 180 spin is going to be super important for people who play non-guideline games with 180 spin. Actually, I'd like to see something. See gesturesses. I believe you can. No, it's not gestress. It's Tetrio. In Tetrio, you can choose. You can choose which kick table you want. Rotate 180. Gameplay. Handling. Wait, what is this? DAS DCD. I don't know what that is. Gameplay. Customization. Nope. Huh. thought you could choose the kick table. Maybe it's gestress. Never mind then. Okay, so this is a good place to stop. Let's try to commit to something else tomorrow. What is it going to be? Invisible mode, force look ahead calculation. Yeah, it's got to be force look ahead calculation because this is going to be a game changer. It'll force you to do the calculation in your head. Just like finesse calculation is forces you to think about the finesse. Force look ahead calculation. I mean, even in those 5 minutes where I was testing it out, I feel like I've already made a ton of progress. Coming up with different rules for pieces that go 2 from the right or 3 from the left, and so forth. Okay, so force look ahead calculation mode. This will be the next one.